Okay, so that was about using some sample data to fit a probability distribution. Okay, so we want that our sample data are representative enough so that our estimation according to the sample is somewhat good. So that may have some problems with sampling techniques. So in this video, we're going to briefly talk about some different techniques and do some comparisons. And because we have the time limit, so we're going to only focus on the most important techniques. Okay, so I want to select a subset of entities from the whole population. So that means I need to decide what to select. And basically I have two ways. I can either do random sampling or non-random sampling. If we do random sampling, then I actually don't know which values will be selected because I do it with a probability distribution. Okay, for example, I probably want to randomly select 1000 phone numbers on the telephone book and then call my consumers. Now, that's something I may want to do. Then the key is that I do it randomly. So I have no systematic way of doing this or doing that. I just do it randomly. If I don't do if I do non-random sampling, then I do things in a deterministic way. Like when I want to do a survey, if I simply ask those guys that are around me, then that's not a random sampling. Or if I select all the people who have the same property, like their phone numbers all ends up with a number 0, then that's deterministic sampling. So considering these two things, you may ask ourselves about if I do it today, if I do it tomorrow, if I do it the day after tomorrow, will I always get the same results or different results? If I always get the same result, that's deterministic. Otherwise, it's probabilistic. Most statistical methods, they only apply to random samples. So starting from now, we will only talk about random sampling. Okay, so the easiest way to do random sampling is obviously simple random sampling, which means each entity has the same probability of being selected. So if I want to do that, I'm going to first assign each entity a label from 1 to, let's say, capital N, and then I'm going to say that I want to generate a sequence of small n-random numbers. Each one should be within 1 and capital N, so that later I'm going to select those entities whose labels are generated in this subset. In that case, we need something called a random number generator. So that's typically some kind of function that if you call it, then you're going to get a random number according to some criteria, like rand and rand between functions in Excel, something we're going to talk about in class. Okay, then sampling with or without replacements may need to be determined. What's that? If I want to select a few values and I allow one value to be selected for many times, then that means once I randomly get one value, I'm going to replace it directly, okay, so that it has the chance to be selected again. That's sampling with replacement. In many cases, we don't want that to happen. Then we do sampling without replacement. That means each value may only be selected at most once. Okay, then that's sampling without replacement. The chance for each value to be collected obviously depends on the way you do the sampling. Okay, so if you want to precisely describe a sampling process, you need to indicate which one you are doing. Okay, so suppose now I want to study all the students graduate from our department and ask about the number of units they took before their graduation. Then let's assume that I actually have 1000 graduates from our department. And now I do have some data. For each student, it has a label. I also know that whether he or she has double major or not. I also know when he or she graduated and the number of units that the student took before he or she graduates. Okay, and suppose that I want to sample, let's say 200 students. So I'm going to do simple random sampling according to this data set. And in this case, because later I want to do some kind of average stuff, so it's not reasonable to select one student twice, right? So that means I want to do simple random sampling without replacement. Once I get one student, I'm going to remove it from the list so that it is not going to be selected twice. Or say it in another way, later I'm going to generate 200 random numbers. They cannot be repetitive. They cannot be repetitive. Okay, so now I generate 200 random numbers, and I mentioned that they cannot be identical. No two values can be identical. Then I'm going to select 200 distinct samples. And then I'm getting 200 students. I'm getting number 2, I'm getting number 7 because they exist in my sequence of random numbers. And then given that 200 students, I can calculate sample mean, sample variance, whatever I want. So that's just that simple. So the good part of simple random sampling is, well, simple. But it may result in non-representative samples. For example, when I was trying to select students and asking them about their units, then if I am so unlucky, then probably all the 200 students in my sample, they did not double major. Then I probably agree that, well, then the sample has some bias because students with double major typically takes more courses and gets more credits. So I probably want to control the number of students in my sample that have double major. Okay? Then I say that sample would be more representative. Okay? So that means I need to have the concept of stratum or strata, which means that I know my data can be split into several strata, and in each strata I want a few values, and typically the number of values is proportional to the size of strata. So that gives me stratified random sampling. Okay, stratified random sampling. First, we would split the whole population into several strata, like those guys in double major or those guys with no double major. And we typically believe or should make it the following. Data in one stratum should be homogeneous, while data in different strata should be heterogeneous. Homogeneous means they are similar or identical. Heterogeneous means they are different. So in our example, we're saying that the relations between double major or not and the number of credits. So we probably believe that for a student with or without double major, their behavior or the value would be relatively heterogeneous because double major does have some impact on whether they take this amount of credits or that amount of credits. Okay, so double major may be a good thing to divide or define strata. And then we use simple sampling, simple random sampling for each stratum. So for example, suppose among my 1,000 graduates, I have 100 students, they had double major. Then we split the whole population into two strata like this. And then, given that we want 200 students in total, in the most typical way, we're going to sample a few students from each group, and the number of students collected from each group is proportional to the size of that group. Like for the double major group, because it contains 10% of the whole population, then I'm going to make 20 students in my sample with double major because that also counts for 10%. Okay, and then 180 from the non-double major group. Then I'm going to perfectly control the impact of double major because I am selecting 10% of students in my sample with double major, which is exactly that percentage in the population. Okay, then this gives me a typically more representative data set. So sometimes we may want to further split the population into more strata. Like we know that students, they have different graduate years, and in the past, students tend to take more credits, but today students tend to take fewer credits. If that's true, then we probably want to split into according to classes. Okay? But of course, when we do this, we need to make sure that, well, that really has some impact. Otherwise, we're simply doing some effort that are useless. Also, we hope that after all the separation, each class should still contain enough number of values. Otherwise, it's going to destroy the property of random sampling. Okay, so stratified random sampling to some degree can be good in reducing sample error, but it may also be hard to do a reasonable stratification. So there is no rule to say whether this is good or that is bad. It depends on our judgment. And of course, it's more costly and time consuming. So if you do not have a good reason to do stratification, then our suggestion is don't do that. Okay? Thank you.